Hi and Assalamualaikum, Dr. Ibrahim and also our fellow friends. We are from Group 8 and is going to present about the chemistry and applications of thorium and uranium. First thing first, let us meet the group members. Hello classmates, again, we are Group 8. I'm Nur Ain Arisha binti Azami with metric number 207895 and my two other partners which are Arman Akram bin Omar 206113 and Muhammad Arif Amirulmune 208172. So now here is a short introduction on the thorium. It is discovered in 1828 by the Norwegian mineralogist Morten Thrin Ismark and was identified by the Swedish chemist which is Hans Jacob Berzelius. A thorium atom has 90 electrons, of which 4 are valence electrons. 4 atomic orbitals are theoretically available for the valence electrons to occupy 5f, 6d, 7s, and 7p. You guys must be wondering about its name, right? It is named after Thor, the Norse god of thunder, which is the same as one of the Marvel characters, which is Thor, that also named after god of thunder. Interesting, isn't it? So let's now explore more about thorium. Thorium is a gray radioactive metal which is fairly abundant in the Earth crust. The special thing about thorium is that it is a basic element of nature. Thorium itself will not split and release energy. Next, thorium is an element of the actinoid series of periodic table. This element can also react slowly with water at room temperature. The texture is fairly soft and malleable, but darkens slowly in air due to the oxidation. Now, it is time for us to move on to the properties of thorium. The melting point and boiling point is 1842 degrees Celsius and 4788 degrees Celsius respectively. Not to forget, it also possesses dimorphic characteristic in which a face-centered cubic changed to a body-centered cubic at 1360 degrees Celsius. The common oxidation state of thorium is positive 4, and it is a paramagnetic. The long half-life of the principal isotope, which is Th232, about 10 to the power of 10 years, ensures that there will be plenty for quite some time to come. Its specific gravity is 11.66, that is 17 degrees Celsius. Last but not least, thorium is a weakly basic oxide. So let's now see some of the examples of thorium with a color that vary from silvery white to a darker color, which is black. Okay, so I'll pass to the next presenter.
Okay, next slide. I will talk about and present about the uranium. So uranium is a chemical element with the symbol U and show the atomic number 92, which is present also the protons or electrons. So uranium also have atomic mass which is shown here 238 and 0.0289. So uranium it is discovered at years 1789 by German chemist Martin Heinrich Klaproth. I'm not sure how it is pronounced. So it is named after the world recently discovered the planet Uranus. So the metal itself was first isolated at years 1841 by French chemist Eugene Melchior Liget by the reduction of uranium tetrachloride with potassium. So in addition, in nature, uranium is found as uranium-238, which is about 99%, and uranium-235, about 0.7%, and a very small amount of uranium-234 is about 0.005%. So for the next slide. So for the next slide, we will talk about more about the uranium. So uranium, it is a radioactive chemical element of the actinoid series of the periodic table. It is a dense hard metallic element which is very white in color. It is ductile, malleable, and capable of taking a high polish. Other than that, it is strongly electropositive, which is when react with water, and it also dissolves in acids but not in alkalis. So the most common isotopes in natural uranium are uranium-238, which has 146 neutrons and accounts for over 99% of uranium on Earth. So for uranium-235, has 143 neutrons. So next slide. So next we will talk about more about the properties. So uranium, it is a very high density, poor conductor of electricity, and it is also a little softer than steel. And it consists of melting point 1000 high melting point, 1132.3 degrees Celsius, and for the boiling point 3818 degrees Celsius. So uranium also, when finely divided, it can react with cold water. When in air, it is coated by uranium oxide, which is tarnished rapidly. Other than that, uranium, uh, don't forget that uranium is orthorhombic crystal structure, one of the orthorhombic crystal structure, which is consists have oxidation state, have 4 oxidation state, 3, 4, 5, and 6. But usually the most stable oxidation state of 4 and 6. So next I will talk about the half-life. For the half-life of uranium-238 is about 40.5 billion years. For the uranium-235, about 700 million years, and uranium-234 about 250,000 years. Next. So this is an example of uranium, which is the color from the silver color metal and to the yellow cake and the green. So how it start from, this is the rock of the uranium that we can see here. This is not pure, and some of it I have green color. So it processed into a pure matte silver color, and they have some interaction with solution, which is can form the yellow cake, and also the green of the rock of the color can form the glass, the green glass of uranium. So that's all from me. Next, I pass to the next presenter.
Okay, thank you. So yeah, and now it's my part, which I'm going to explain a bit more about the application of thorium and uranium. So first, we dive in regarding the application of uranium first. So first, uranium as nuclear fuel. Uranium is used in nuclear reactor to generate electrical power, which in electricity generation in nuclear reactor has many similarities to more conventional electricity generation. In that, the generated thermal energy is used to drive the turbo generator. The breakdown of one atom of uranium produce much as energy is released by the combustion of molecule of a petrol. Sorry. So there are also the second application of uranium, which uranium in radioactive isotope. There are many major other use of uranium through the production of radioisotopes, including medicine, where radioisotopes are used for diagnosis and research Radio diagnosis can be used to detect disease by injecting a certain radio element into the human body and observing their path. Secondly, is in food processing industry, where radioisotopes are used to sterile fresh product because irradiation can kill parasite, pests, and also bacteria. And last, we have the industrial sector, where radioisotopes are used for industrial X-ray requirements. Okay, next, the application of thorium. So similarly to uranium, thorium is also used in nuclear fuel. So thorium is not itself a fissile, and so it is not directly usable in the thermal neutron reactor. However, it is fertile and upon absorbing a neutron will transmute to uranium-233, which is excellent fissile fuel material. Though thorium fuel therefore need a fissile material as a driver so that the chain reaction can be maintained. And the only fissile driver option are uranium-233, uranium-235, and plutonium-239, which it's hard to say because all of these three driver are hard to get material. And secondly, for application of thorium, we also have this as source of multiple medical isotope. So researchers have developed a new method to recover radium isotope for cancer treatment. The process begins with the dissolved proton irradiated thorium target solution, which then the process then takes the solution through a several series of columns. In each column, different isotope bind to the different substrate that the columns contains. With the anticipated scale up to a large thorium targets, dozens of patients treatment doses will be available for recovery from a single production process. So that's pretty much it regarding the chemistry and application for thorium and uranium. And that's conclude our presentation from our group. Thank you.